Welcome back to the DIY Off-Grid channel, the show where we explore eco-friendly innovations and tackle the big questions about sustainability. I'm your host, Rancher Pete, and today we're diving into one of the most debated topics in clean energy, the carbon intensity of lithium battery production. It's a continuation of our topic yesterday where we talk about the energy required to manufacture green energy systems and to dispel the notion that technologies associated with green energy, such as solar panels, wind turbines, and batteries, will never pay back for themselves in energy consumption. Lithium-ion batteries power everything from electric vehicles to smartphones, but the process of making these batteries has a carbon footprint. So how green are they really, and how do they stack up against fossil fuels when we consider the environmental impact over the life of the vehicle? Let's charge up for a deep dive into this electrifying topic. If you watched our last segment, we pointed out that manufacturing a solar panel requires around 250 watt-hours per watt to manufacture, while it can output 36,000 watt-hours to 90,000 watt-hours over the life of the panel itself. Using those numbers, producing 1 kilowatt-hour of electricity using solar panels produce about 1.1 to 2.8 grams of CO2. If we charge the electric car with electricity generated from natural gas or coal, however, 1 kilowatt-hour produces 408 grams of CO2 for natural gas and 1,031 grams of CO2 for coal. Suppose an average car that gets about 25 miles per gallon that's driven 15,000 miles a year for 15 years. That's a total of 225,000 miles, and it'll burn through roughly 9,000 gallons of gas in that process. Not even taking the manufacturing of the car into account, the fuel consumption alone will generate about 80,000 kilograms or 176,000 pounds of CO2 during those 15 years of operation. That's some 88 tons, or about as much as 3 or 4 semi-truckloads of CO2. If we use an electric car that gets 3 miles per kilowatt hour, which is pretty middle of the road, and drive the same distance per year for 15 years, it comes out to 75,000 kilowatt hours of electricity consumed. Now, if we use the carbon emissions from solar calculated above, using that worst case scenario of 2.8 grams per kilowatt hour, it comes out to just 213 grams of CO2 or 469 pounds of CO2. Just a tiny fraction of how much is produced while driving an ICE car. Now, of course, that's assuming all the electricity comes from solar energy, which is entirely possible if you have a large enough array at home. But let's switch gears just to using grid power based off of natural gas and coal. At 75,000 kilowatt hours, you would produce about 30,000 kilograms or 67,000 pounds of CO2 using natural gas, and upwards to 77,000 kilograms or 170,000 pounds of CO2 using coal. Clearly, there's no advantage with using coal as a power source, and thankfully that's being phased out here in the United States because of how inefficient and costly a coal power plant is, but the reductions are still quite favorable if the grid utilizes natural gas. Now, I had to dig a little deeper to figure out the energy required to produce 1 kilowatt hour of lithium batteries, and depending on the specific battery chemistry, that can range quite a bit. It can be as low as just over 20 kilowatt hours for the latest NCM 900 batteries to around 37.5 kilowatt hours for LFP batteries, with NCA and other NCM variants somewhere in between. Now, assuming an average electric car battery of 60 kilowatt hours, we're talking about 1,200 to 2,250 kilowatt hours of energy to manufacture the battery cells. This is a bit of a simplified calculation as it only takes the assembly of the battery cells into account, not the mining and logistics costs of the materials. But going back to our discussion yesterday, the price takes into account all the energy costs required to produce the battery. So what does the energy cost of producing the EV batteries look like from a CO2 emissions viewpoint? Well, it comes out to 500 to 900 kilograms of CO2 emissions if we're using natural gas, and 1,250 to 2,300 kilograms of CO2 emissions if we're using coal as the power input. In our wonderful American pounds, that's about 1,100 to 2,000 pounds of CO2 emissions using natural gas, and 2,800 to 5,100 pounds of CO2 emissions using coal. Now, it's rather interesting to see those figures for car battery production because the Volkswagen Group actually published data showing how much energy it requires to manufacture a car for the group overall. In 2023, that number came out to 1,991 kilowatt hours. Now that implies that the EV battery itself can increase the initial energy intensity of production of a car by some 60 to 110%. But it goes on to prove that a far greater proportion of carbon emissions come from running an internal combustion vehicle versus driving an electric car powered by renewable energy. The way I present this topic to my viewers is this way. There are almost none amongst us that can produce hydrocarbons at home. I did have a few viewers chime in saying they produce biodiesel on their farms, and another viewer saying they make their own ethanol. I mean, moonshine. But realistically speaking, you and I can't produce enough fuel to drive our ICE cars, if any. On the other hand, producing energy from solar panels is not only easy to do, but practical and fiscally responsible to do in 2024. The average American drives only about 40 miles per day. That's about 13 kilowatt hours of energy per day, which only takes a 4,000 watt solar array to produce. Now, on our next segment, we'll take a look at this not from a carbon emission stance, but from a financial viewpoint. How much does it cost to run an electric car using solar energy versus charging from the grid or third-party chargers, compared to the cost of running a gasoline or hydrogen fuel cell powered counterparts? Now, again, lithium batteries, they're not an automatic panacea to eradicate all pollution, but that's why we do these deep dives, to actually get to the raw numbers and see how it compares to conventional alternatives. Compared to the ongoing emissions of burning fossil fuels, lithium batteries present a clear path forward. They're not just a part of the solution, they're a cornerstone of a sustainable transportation revolution here. Now, again, thanks for tuning in to the DIY Off-Grid channel. If you've enjoyed this episode or have any questions about sustainable technology, do feel free to reach out to me on social media. Until next time, stay green and let's keep driving towards a better tomorrow.